Okay, you're going to look at an exam question involving upper bound and lower bound as part of the GCSE maths syllabus. Let's take the first question then. So this question, let's read it together. The voltage V of an electronic circuit is given by the formula V equals IR. Hopefully you've come across this formula before in your physics. I is obviously the current in amps, R is the resistance in ohms, and then V is the voltage across a circuit. The question gives us the value of V. It's telling us it's 208 volts, correct to three significant figures, and it's giving us the resistance, which is 12.8 ohms, correct to three significant figures, and it's asking us to work out the lower bound of the current I. So let's see how we go about doing that. Okay, so first of all, we take the value for V that they've given us, 208 volts, and we work out its upper bound. So the upper bound, to all intents and purposes, is 208.5 volts, and the lower bound is 207.5. We then look at the R value that they've given us. They've given us the R is 12.8, correct to three significant figures. And once again, we work out the upper bound, which is 12.85, and the lower bound, which is 12.75. Now, to calculate the lower bound of the current, we have to rearrange this original formula that they've given us. V equals IR into I equals V over R. I equals V over R. And in order to get the lower bound of the current, we need to then use the lower bound of the voltage divided by the upper bound of the resistance. And here you have it here. So we put our value 207.5. We've used the lower bound of the voltage divided by 12.85, which is the upper bound of the resistance, to give us 16.15 amperes to two decimal places.